on. Now I'm discussing the second lecture of stability of slope. Okay, in that lecture we are going to find out the factor of safety of the material. That is a factor of safety of slopes. We are going to find out. Okay, in the entire chapter, and to check the stability of the slope against the sliding. Okay, so in general we know that. So again, the sloping surface. Suppose this is our section of the section of the dam, half section of the dam. Okay, so due to this inclined surface, what will happen? Due to this self weight, the soil tends to move in a downward direction. Okay, so this force, which is called as the driving force, okay, and which is called as the shearing stress into the soil material. Okay, to avoid this failure or to avoid this sliding, we have created some resistance in upward direction in the form of cohesion, okay, or which is called as a resisting force. Okay, so this resisting force, the strength of the soil along the slip surface, that is buttresses at the toe, means this is the toe portion. So from here we are creating some resistance to avoid this sliding. Okay, so there are two forces. The first force, that is the driving force, which is due to self weight, which is called as the sliding. And to avoid this sliding, okay, we are creating some resisting force, that is in upward direction due to some this cohesion of this material, okay, which is acting from this toe point in the upward direction. So our slope will be stable. If this factor of safety is less than 1. Okay, so what is meant by the factor of safety? So factor of safety we can designate it as the ratio of the resisting force, to the driving force. Okay, resisting force to the driving force. So theoretically, any slope with a factor of safety which is less than 1 will fail, and slope with a factor of safety greater than 1 will not fail. Okay, so as a engineering point of view, while designing any kind of slope, it may be that is finite slope, any kind of finite slope, that is finite slope is a man-made slope. Okay, that is either a design of dams, that is other dams. So we have to check its factor of safety. So if the factor of safety is greater than 1, our slope will be stable, the material will not be slide. If the factor of safety is less than 1, the chances of the sliding of the material. Okay, so this design focuses on the soil parameters and the geometry that will be provide the maximum factor of safety. So sometimes the analysis of the existing slope will be what is called as a parametric study. Okay, that is establishing a factor of safety and performing an analysis that calculate the strength parameters. The engineer will then determine his confidence level as whether or not the soil has strength through experience, by lab, or by field data. Okay, so in this whole unit, that is unit number 6, that is stability of slopes, we are going to find out the factor of safety of the slopes, okay, by using this formula, that is the resisting force or driving force. Okay, so for that purpose we need the concept of the that is shear strength. Okay, so this resisting force, that is this resisting force is nothing but that is the shear strength of the soil. Okay, means the strength of the soil to resist the failure along the sloping surfaces, and upon the driving force is called as the shear stress developed along the potential failure, means the stresses developed due to the sliding along the surface. So we can write as tau. Okay, so this shear strength that can be calculated. So Fs equal to our formula now, Fs equal to S upon tau. Okay, so depending upon number of books, for the concept is same, that is shear strength upon shear stress developed. Okay, but this symbol will be different. So here we are going to use the symbol as S, that is the maximum shear strength of the soil, and tau, that is the maximum shear stress developed along the potential failure. Okay, so this factor of safety, that is S upon tau. So we need so what is meant by S? S means the shear strength of the soil. The shear strength of the soil that can be calculated by using Mohr-Coulomb law. We know the Mohr-Coulomb law. In unit number 4, we had discussed about the Mohr-Coulomb law. So Mohr-Coulomb law states that S equal to C plus sigma tan phi. S equal to C plus sigma tan phi. Okay. Okay. S equal to C plus sigma tan phi. That is our formula. Okay. So here we are not considering the pore water tan of phi. So where C is called as a cohesion, phi is called as the internal friction, sigma is a normal stress, S is a shear stress. Okay. So in here, so we are taking as a total stress, that is sigma is taken as total stress, but in terms of effective stress, the formula will be, that is S equal to C dash plus sigma dash tan of phi dash. So this is also called as the modified Mohr-Coulomb theory. Okay, so where C dash is called as the effective unit cohesion or cohesion in terms of the effective stress. Sigma dash, that is called as effective normal stress. Okay, that can be calculated by using formula sigma minus U. So sigma is our total stress, U is our pore water pressure, okay, or a neutral stress. And phi dash is the effective angle of friction or internal friction which is related with the effective stresses. Okay, so this is formula for when we are considering the pore water pressure. If we are not considering the pore water pressure, our formula will be that is S equal to C plus sigma tan of phi only. Okay, and if we are considering the pore water pressure or water pressure, so formula in terms of the effective stress, it will be S equal to C dash plus sigma dash tan of phi dash. Okay, so so in this chapter, factor of safety, we are calculating the factor of safety with respect to three parameters. First of all, factor of safety with related to shearing strength. Second is factor of safety with respect to cohesion, and next one, that is factor of safety with respect to height. And we are also going to find out the factor of safety with respect to angle of internal friction. So this factor of safety, so we know the formula. What is the formula? That is Fs equal to S upon tau, equal to, here S means the shear strength of the soil. So here we are taking, that is a unit shear strength of that is effective shear strength of the soil, that is C dash plus sigma dash tan of phi dash. This formula is we are considering the effective pore water pressure. So that's why the S equal to C dash plus sigma dash tan of phi dash upon tau. So tau is nothing but the maximum shear stress. Okay, at the we are taking the mobilizer value. Okay, so the formula becomes, the value of tau is same as, that is Cm that is Cm dash plus sigma dash tan of phi m dash. Okay, because we are considering the mobilized value of cohesion and internal friction. So here it is simple way, we can write as this, that is C dash plus sigma dash tan of phi dash. This is the formula for shear strength, and upon tau the formula will be C. So here we are at Cm dash plus sigma capital dash, that is tan of phi m dash. Okay, the same formula will be here. Both the terms are same, S and tau. Okay, only difference is that S is the shear strength, tau is the shear stress. So here we are considering F as the factor of safety with respect to cohesion. So if you want to calculate the factor of safety with respect to strength, that is shear strength, so we can designate FC as Fs, that is factor of safety as Fs. Okay, so as we know, we are going to calculate the factor of safety for four different parameters. First is respect to reference to strength, that is shear strength, we can call as Fs. Second, that is respect to cohesion, we can call as FC, C for cohesion. Then for internal friction, that is phi, that is factor of safety with respect to cohesion, that is F phi. And then if you want to calculate the factor of safety with respect to height, we can call as Fh. Then the tau is also, we know that tau means the mobilizer shear strength, or this is a mobilizer shear stress, we can call it the mobilizer shear stress. That is the stresses develop into the soil due to the sliding. Okay, and Cm, this is a mobilizer cohesion, phi m dash, that is mobilizer angle of internal friction, and S is our maximum shear strength of the soil. So this formula, so same formula is here, that is S equal to tau Fs. So Fs equal to S upon tau. So where we know that S equal to, what is mean by S? S equal to, that is S equal to C dash plus sigma dash tan of phi dash upon, for tau means same formula, so write down same formula, C plus sigma tan phi, so dash dash. So instead of C we can write as Cm, and phi we are writing phi m, because it is a mobilizer value of cohesion and angle of internal friction. Okay, so this formula also we can write in terms of tau. In terms of tau we can also write as, that is C dash upon Fs. Okay, because this value C dash upon Fs, we are separating the term, that is C plus sigma tan phi, right? So that is Fs equal to upon tau. Okay, so if you take tau towards this side, so what will be the our formula? So tau equal to C plus sigma tan phi upon Fs. Okay, if you write the both the terms separately, so this term separately and this term separately, it will be looks like that, that is it will be like that, that is tau equal to C dash upon Fs plus sigma dash tan of phi dash upon Fs. Or we can also write as, because we know the value of tau is Cm dash plus sigma tan of phi m dash. Okay, so where this Cm is equal to C dash upon Fs is nothing but, that is nothing but this formula is like that, C dash plus sigma tan of phi dash upon Cm dash plus sigma tan of phi m dash. Okay, if you write this term separately and this term separately, okay, that is C dash upon Cm dash and sigma tan of or we can also write because sigma get, suppose we are cancelling term, or tan of phi dash upon tan of phi m dash. Okay, so our formula became, Fs equal to C upon Cm dash, and Fs equal to tan of phi upon tan of phi m dash. Okay, so if you take this term toward this side and this term toward this side, so it will be Cm dash equal to C dash upon Fs, and tan of phi m dash equal to tan of phi dash upon Fs. So here, we can also call as, so this is the first factor of safety. This is the first factor of safety. Safety according to shear strength is Fs equal to S upon tau. That is C dash plus sigma tan of phi dash upon Cm dash plus sigma tan of phi m dash. This is the first factor of safety, that is factor of safety with respect to shear strength. Then second factor of safety with respect to cohesion, so we can call as Fc, for factor of safety with respect to cohesion is as C dash upon Cm dash. that is cohesion, that is cohesion due to effective stress upon the mobilizer value of the cohesion. It is the ratio of cohesion due to effective stress upon the mobilizer value of the cohesion. Then third factor of safety with respect to angle of internal friction, so we can call as f phi equal to tan of phi dash upon tan of phi m dash. That is the ratio of angle of internal friction with respect to effective stress to the mobilizer value of angle of internal friction. Okay, this is the third factor of safety. Okay, so we have the three factor of safety. The fourth one is also, that is the factor of safety with respect to height is also there, but we have only three, that is factor of safety with respect to shear strength, factor of safety with respect to cohesion, and factor of safety with respect to angle of internal friction. Okay, so noted that factor of safety is the ratio of maximum shear strength to the maximum shear stress, that is Fs equal to S upon tau. Fs equal to Fs upon tau. Okay, it is noted that this is important. From that we are going to analyze the that is stability of the slope for different kinds of soil. Okay, for infinite slope and finite slope. Okay, so the our next part or next lecture is that is stability analysis for infinite slope and finite slope. So what is mean by the stability analysis? What are we are going to check? Stability analysis, this term is defined at the resistance to the sloping surface to the failure by sliding or collapsing. It means we have creating some resistance and we are checking the factor of safety against the sliding. That is nothing but the stability analysis. That is resistance of the sloping surface to the failure by sliding or collapsing. So in that we have to solve this step, we have to check the stability of the slope for the following conditions. The first case is infinite slope in a sand, that is cohesionless. Sand is nothing but cohesionless soil with dry soil. We are taking this sand, but it contains no amount of water. Okay, only dry sand we are going to consider and check its stability. If your sloping surface, if suppose your sloping surface, this is your sloping surface, and this sloping surface which consists of only sand, it contains no any water, so we have to check the factor of safety. Okay, while designing we have to check the factor of safety of it by using this formula F equal to S upon tau. Okay, S upon tau. So likewise second, that is infinite slope in a sand, but there is a fully submerged condition, means the water content is there, means soil plus water will be there. Okay, so this is the second case. If your slope contains soil plus water, that is submerged condition. Then next is infinite slope in sand, that is sand, or we can call as a cohesionless soil. So we know that the cohesionless soil which is having two types, that is first is gravel, second is the sand. Okay, so here we are taking the sand as a cohesionless soil. Okay, so in that if the water table is arises at some depth, okay, so in the first case there is no soil, sorry, no water. Okay, first case, this whole slope, this is slope, no? This is inclined surface, the whole slope which contains only soil. Second case, this slope contains soil plus water. Okay, soil plus water. Third case, if the water table which is at some depth, suppose water table is at depth, and this is surface which is inclined surface is filled with soil. Okay, this is called the partially submerged, or here in the language of stability of slope we can call as seepage parallel to the slope and water table at any depth. Then infinite slope in sand and that is cohesive soil and cohesionless soil. If the soil, if your inclined strata which contains cohesive soil as well as cohesionless soil, means sea soil and phi soil. We know that sea soil means the cohesive soil, and phi soil, that is the cohesionless soil, that is sea phi soil. Then what will be the analysis? And last one, if your inclined surface which consists only clay, that is if your inclined surface which is subject to only cohesive soil. From that we are going to find out the factor of safety. So all these cases we are going to find out the factor of safety. What will be the factor of safety? Either your slope will be stable or not, that we are going to be check. Okay. For these five conditions. And next one, these are some graphical methods. That is, first is the Taylor stability number. So this is also one method. From that we are going to find out the factor of safety of the material by using the number of charts. Okay, so Taylor is a scientist who found who actually doing the study of number of angle of friction and cohesion, and drawing a number of charts. From the charts we pick the value, we take the value and find out the factor of safety of the material. That is called the Taylor stability number. Second, that is the Swedish slip circle method. So it is also one of the method that is we can call it the graphical method. From that we can find out the factor of safety of the material. Last one, that is the friction. So next one, that is the friction circle method. So in that method where this is also graphical method, and we can also solve by using analytical method and finding the factor of safety of the material. And next, that is the Bishop's methods. Okay, Bishop's method. So next lecture we will discuss about all these parameters. Okay, so this is our second lecture. So from the next lecture we are going to be discuss, that is the stability of infinite slope. Okay, so for that purpose we need the basic mechanics. Okay, you know the what is meant by the resultant force, what is normal force, and what is shear force. Okay, and from that we are going to be find out the factor of safety of the material. Okay, thank you.